Here are some gas equations. PV equals a third capital N M root mean square speed squared. The average kinetic energy per molecule is 3/2 kT. K is Boltzmann's constant. T is temperature measured in Kelvin. Average kinetic energy per mole is 3/2 RT. PV P1 V1 divided by T1 is equal to P2 times V2 divided by T2. PV equals nRT, so pressure measured in pascals, V volume measured in meter cubed. Small n is the number of moles, R is 8.31, T is temperature in Kelvin. PV equals capital N KT, where capital N is the number of particles, K is Boltzmann's constant, and T is temperature, again measured in Kelvin. So the questions, you've got question A, calculate the molar mass of a 5.67 gram sample of a gas if it occupies 0.0256 meter cubed at 3 degrees Celsius and 152,000 pascals. Leave your answer in grams per mole. Question 2, what is the molar mass of a gas if 7.8 grams of it occupies 0.0067 meter cubed at 75 degrees Celsius at 105,000 pascals? Leave your answer in grams per mole. For these three questions, take 1 atmosphere as 101,000 pascals. I think it's normally 101,350 pascals, but just take one. It says here, it says take 1 atmosphere as 101,000 pascals. So questions B. A 0.005 meter cubed vessel contains nitrogen gas at 27 degrees Celsius and 3 atmospheres. Find A, the total kinetic energy of the gas molecules, and B, the average kinetic energy per molecule. Question 2, what is the root mean square speed of an oxygen molecule in the air if the temperature is 5 degrees Celsius? Assume the mass of an oxygen molecule is 5.3 times 10 to the minus 26 kilograms. Question 3, a cylinder contains a mixture of helium and argon gas in equilibrium at 150 degrees Celsius. What is the average kinetic energy of each type of gas molecule? B, what is the root mean square speed of each type of molecule? So you've got some information from the periodic table. Helium, the atomic, the proton number is 2, the atomic mass is 4. Neon, the proton number is 10, and the mass is 20.179. Argon, the proton number is 18, and the mass is 39.948. So if you don't remember, it just means that the number of protons in argon is 18. For a normal atom, it should have 18 electrons as well because it cancels out the charge. And 1 mole of argon would weigh, well, would have a mass of 39.948 grams. So 1 mole of neon would have a mass of 20.179 grams. Question C, a container of oxygen gas has a volume of 0.001 meter cubed at 40 degrees Celsius and a pressure of 1 atmosphere expands until its volume is 0.0015 meter cubed and the pressure is 1.05 atmospheres. Calculate the number of moles of oxygen. B, what is the final temperature of the gas? Question 2, 3 moles of an ideal gas are contained in a 0.075 meter cubed container at a pressure of 1.6 atmospheres. What is the temperature of the gas? What is the total kinetic energy of all the molecules of the gas? C, if the gas is diatomic hydrogen with a molar mass of 2.00 grams per mole, what is the root mean square speed of a diatomic hydrogen molecule? If the volume of the container containing the gas was decreased by half while keeping pressure at the same value, by what factor will the average root mean square speed of the molecules change? So these are the answers, hints for the slide where it says question A. So you got the values M, V, T, and P. You convert the Celsius into Kelvin. Use the equation PV equals nRT. Rearrange for n the number of moles. So put the numbers in. You should get 1.6965765 moles. But the question is asking for the molar mass. So molar mass is equal to mass divided by the number of moles. You've worked out the number of moles, which is roughly 1.7, and you've got the mass in the question. So you do mass divided by the number of moles. But I did it in kilograms, but the question says leave your answer in grams per mole. So the answer should be 3.34 grams per mole. The next part, you should get, it's just a similar method. You should get 32 grams per mole. The slide where it says questions B, use PV equals nRT, PV equals third nmv squared. Now, because the question is asking for the total mass of all the particles, it's asking you use the equation where it says capital NM, because capital NM is the total mass of the particles. So you should get kinetic energy is 2272 or 2272.5 joules. The average kinetic energy per molecule. For this question, you use the equation kinetic energy is 3/2 kT. You know the temperature, which is 5 degrees Celsius. You add 273, and you're given M in the question, and you know what K is. K is just a constant. So you should get 466 meters per second. Question D. What is the pressure in atmospheres exerted by 2.48 moles of a gas in a 0.25 meter cube container at 58 degrees Celsius? A sample of oxygen gas occupies a volume of 0.4362 meter cubed at 103,351.5 pascals. If the temperature is held constant, what would the pressure of this gas be when the gas is compressed to 0.2316 meter cubed?